Hello friends, today I'll discuss how the overcurrent relay is coordination for distribution radial system. So in this diagram, a radial distribution system has been shown while substation end is connected with source, and in between substation B and A we have one distribution line, and again from substation B to C is connected via one distribution line, and again in the substance C to D connected via distribution line. So load is connected all the substation, that is D, C, B and A. Okay, so this is the CT and this is the breaker for substation A end for this line, and CT and breaker for substation B end for line which is connected in between substation B to C, and this is the CT and breaker for substation C end for a line which is connected between C and D. Okay, so relay is connected from the CT secondary side. So R1, R2, R3 are the three relay which is connected at substation A, B, and C end. So how the this overcurrent relay is coordinated from this substation for this radial system. So in this case, we have to consider the fault at substation D and bus. So in this case, let us consider that fault current at substation D and bus is 4000 ampere. So this fault current will be sensed by this all these three relay. Okay. So we have to coordinate it from substation C and relay, that is from R3. Then we from R3 to R2 from R1. So how this relay coordination is done, I will discuss in this video. So normal inverse, IC normal inverse or standard inverse characteristics is chosen for coordination of overcurrent relay. So as per IC normal inverse or standard inverse curve, the trip time is given by trip time is equal to 0.14 into TMS. TMS is the time multiplier setting in second and divided by PSM to the power 0.02 minus 1. Okay. So this is the characteristics of IC standard inverse curve. So PSM is the flux setting multiplier which is given by the ratio of the fault current to the relay pickup current. So by this curve we will coordinate between relay R3, R2 and R1 for overcurrent relay. Okay, so let us choose the relay TMS for relay R3 which is connected at substation CN as TMS as 0.05 second. Okay, and CT ratio is 400 by 1 as per secondary relay pickup set as full load of the CT current, that is 1 ampere in terms of secondary value or 400 ampere in terms of primary value. Since the fault current is 4000 ampere, this fault current will be sensed by relay R3. So IF is equal to 4000 ampere. PSM comes as ratio of the fault current to the relay pickup current. Since the relay pickup current is 1 ampere in terms of secondary value, it comes as primary value as 400 ampere. So PSM comes as ratio of fault current divided by relay pickup, which comes as 4000 divided by 400 is equal to 10. So relay trip time as per chosen TMS, that is 0.05, comes as 0.14 into 0.05 divided by PSM to the power 0.02. In this case, PSM is equal to 10 to the power 0.02 minus 1, which is equal to 0.148 second or 148 millisecond. Let us say that trip time is 150 millisecond or 0.15 second. Since the trip time for relay R3 is 0.148 second, let us say that 0.15 second. So for relay R2, we have to choose some time margin. In this case, we have chosen the time margin for 150 millisecond or 0.15 second from that of the trip time of the relay R3. So in this case, for R2, trip time will be time margin, that is 0.15 second for relay operating time for relay R3. So it is 0.15 plus 0.15 is equal to zero point 0.3 second or 300 millisecond. In this case, the relay pickup is set as 1 ampere. There is a full load of the CT ratio. There is like 400 by 1. So in terms of secondary value, it is chosen as 1 ampere. So fault current is 4000 ampere. PSM, that is the plug setting multiplier, comes as 4000 divided by relay pickup. In terms of primary value, it is 400 ampere. So PSM comes as 10. So we have to calculate the value of the TMS. So here the TMS comes as per the IC normal inverse or standard inverse curve. That is trip time. That is trip time here is given as 0.3 is equal to 0.14 into TMS divided by 10 to the power 0.02 minus 1. So TMS comes as 0.1 second. Okay. Now for relay R1, the trip time shall be the relay trip time of the relay R2 plus time margin of 150 milliseconds. Relay R2 trip time is 0.3 second plus 0.15, which is the trip time for the relay R1, that is 0.45 second. Now relay pickup is 0.75 ampere or 75% of the CT ratio. So in terms of the secondary value, it is 0.75 ampere. In terms of the primary value, it is 400 ampere. Since the fault current is 4000 ampere, so value of the plug setting multiplier will be again same. That is the fault current divided by relay setting. That is the 400 ampere is equal to 10. So since the trip time is equal to 0.45 second, we have to calculate the value of the time multiplier setting. So here from this equation of the IC standard inverse curve, 0.45 is equal to 0.14 into TMS divided by 10 to the power 0.02 minus 1. So value of the TMS comes as 0.15 second. Okay. So as per the relay coordination for this distribution radial system, pickup of relay R2 and R3 is same, that is the 100% of the CT ratio, but in case of the relay R1, it is 75% of the CT ratio. So TMS for R3 is equal to 0.05, which has been set predominantly, and for relay R2 and R1, which is calculated from the relay operating time of R3, and some time margin has been chosen. And from this, the TMS value comes as for a relay R2 is 0.1 second and for relay R1 is 0.15 second. So this is how the relay coordination is done for our current relay for distribution radial system. Thank you for watching this video.